The heart of the fermentation or bioprocess technology is the fermenter or bioreactor. A bioreactor is basically a device in which the organisms are cultivated to form the desired products. It is a containment system designed to give right environment for optimal growth and metabolic activity of the organism. A fermenter usually refers to the containment system for the cultivation of prokaryotic cells, while a bioreactor grows the eukaryotic cells. Different types of bioreactors are stirred tank bioreactor, airlift bioreactor, fluidized bed bioreactor, packed bed bioreactor, photobioreactor, membrane bioreactor, rotary drum bioreactor, and mist bioreactor. Stirred tank bioreactor. In stirred tank bioreactor, the contents of the vessel no longer vary with time. This applies to the hold-up of microorganisms and the concentration of the components of the medium in the fermenter. Steady-state conditions can be achieved by either chemostatic or turbidistatic principles. In chemostat, the adjustment of the flow rate of the fermenter to an appropriate and constant value and allowing the microorganisms, substrates and biochemical product concentration to attain their natural levels. The turbidistat requires an experimental determination of the turbidity, that is the indirect measurement of microbial concentration. This thus used to control the flow rate. Advantages of stirred tank bioreactor: continuous operation, good temperature control, easily adapts to two-phase runs, good control, simplicity of construction, low operating cost, easy to clean. Disadvantages of stirred tank bioreactor: the need for shaft seals and bearings, size limitation by motor size, shaft length, and weight. Airlift fermenter. Airlift fermenter works on the principle of an airlift pump. It is of two types: internal loop type and external loop type. The reactor's volume is determined by its capacity, kinetic data, and the specific growth rate of the organism used. The rate of airflow of the reactor depends on the volumetric mass transfer coefficient in the reactor system. It is uniform cylindrical cross-type and has an internal loop or external loop riser configuration. The external loop riser configuration is adjustable, and the change in the configuration improves the oxygen transfer rate via mass transfer coefficient for a particular rate of airflow. This helps to provide required dissolved oxygen concentration for specific microbial system. Advantages of airlift fermenter: simple design, without any moving parts or agitator, less risk of defects. Easier sterilization, no agitator shaft parts. Low energy requirement compared to stirred tank. Greater heat removal compared to stirred tank. Very low cost. Disadvantages of airlift bioreactor: greater air throughput and higher pressures needed. The agitation on the airlift bioreactor is controlled by the supply air. To adjust the supply air, then the higher pressure needed. And if the higher pressure of air needed, then more energy consumption needed. And more cost must pay. Inefficient: break the foam when foaming occurs, because there is no blade/shaft as a foam breaker. Compare with the stirred tank that has it at the surface. No bubbles breaker: there are no blades that used as a breaker the bubbles which produced from the air supply, sparger. Packed bed reactor. In packed bed reactors, cells are immobilized on large particles. These particles do not move with the liquid. Packed bed reactors are simple to construct and operate, but can suffer from blockages and from poor oxygen transfer. Advantages of packed bed bioreactor: higher conversion per unit mass of catalyst than other catalytic reactors. Low operating cost. Continuous operation. No moving parts to wear out. Catalyst stays in the reactor. Reaction mixture or catalyst separation is easy. Design is simple. Effective at high temperatures and pressures. Disadvantages of packed bed bioreactor: undesired heat gradients. Poor temperature control. Difficult to clean. Difficult to replace catalyst. Undesirable side reactions. Fluidized bed bioreactor. In this, beds of regular particles suspended in an upflowing liquid stream. If an additional gas phase is involved, there is a tendency for the particles in the bed to become less evenly distributed. There are two important features for the beds of mixed particle sizes. First is the increase in porosity from the bottom to the top of the bed, and the second is the decreased particle movement when compared with beds containing particles of constant size. Since porosity or voidage is a measure of the local free space within a bed, it also represents a measure of the microbial hold-up when expressed as wet volume per unit bed volume. Thus, a variation in microbial hold-up is to be expected within a fluidized bed fermenter. On fluidization, the smaller particles rise relative to the larger particles, and produce a situation where the smaller particles are at the top and the larger particles are at the bottom of the bed. As the smaller particles have the lowest settling velocity, the bed arranges itself, so that the smaller particles may be in the region of the highest porosity and the lowest linear velocity. The tower fermenter, developed for the continuous production of beer, is based upon these general principles. Advantages of fluidized bed reactor. Uniform particle mixing. Due to the intrinsic fluid-like behavior of the solid material, fluidized beds do not experience pore mixing as in packed beds. This complete mixing allows for a uniform product that can often be hard to achieve in other reactor designs. The elimination of radial and axial concentration gradients also allows for better fluid-solid contact, which is essential for reaction efficiency and quality. Uniform temperature gradients. Many chemical reactions require the addition or removal of heat. Local hot or cold spots within the reaction bed, often a problem in packed beds, are avoided in a fluidized situation such as in fluidized bed reactor. In other reactor types, these local temperature differences, especially hot spots, can result in product degradation. Thus fluid bed reactors are well suited to exothermic reactions. Researchers have also learned that the bed-to-surface heat transfer coefficients for fluidized bed reactors are high. Ability to operate reactor in continuous state. The fluidized bed nature of these reactors allows for the ability to continuously withdraw product and introduce new reactants into the reaction vessel. Operating at a continuous process state allows manufacturers to produce their various products more efficiently due to the removal of startup conditions in batch process. Photobioreactor. Photobioreactor is a type of bioreactor which is used to cultivate phototrophic microorganisms, or organisms which grow by utilizing light energy. These organisms use the process of photosynthesis to build their own biomass from light and carbon dioxide. Members of this group are plants, mosses, macroalgae, microalgae, cyanobacteria and purple bacteria. Key objective of a photobioreactor is to provide controlled supply of specific environmental conditions for respective species. Thus, a photobioreactor allows much higher growth rates and purity levels than anywhere in natural or habitats similar to nature. Advantages of photobioreactor. Cultivation of algae is in controlled circumstances, hence potential for much higher productivity. Large surface-to-volume ratio. Photobioreactors offer maximum efficiency in using light and therefore greatly improve productivity. Typically the culture density of algae produced is 10 to 20 times greater than bag culture, in which algae culture is done in bags and can be even greater. Better control of gas transfer. Reduction in evaporation of growth medium. More uniform temperature. Better protection from outside contamination. Space saving. Can be mounted vertically, horizontally, or at an angle, indoors or outdoors. Reduced fouling. Recently available tube self-cleaning mechanisms can dramatically reduce fouling. Disadvantages of photobioreactor. Capital cost is very high. This is one of the most important bottlenecks that is hindering the progress of algae fuel industry. Despite higher biomass concentration and better control of culture parameters, data accumulated in the last 2 decades have shown that the productivity and production cost in some enclosed photobioreactor systems are not much better than those achievable in open pond cultures. The technical difficulty in sterilizing these photobioreactors has hindered their application for algae culture for specific end products such as high-value pharmaceutical products. Membrane bioreactor. Membrane bioreactors are successfully applied to various microbial bioconversions such as alcoholic fermentation, organic acid production, wastewater treatment. In membrane bioreactor, the soluble enzyme and substrate are introduced on one side of ultrafilter membrane by means of a pump. The product is forced out through the membrane. The membrane holds back the enzyme. Good mixing in the reactor can be achieved by using a stirrer. The most widely used membrane materials includes polysulfonate, polyamide, and cellulose acetate. Advantages of membrane bioreactor. The loss of enzyme is reduced. Enzyme lost by denaturation can be made up by periodic addition of enzyme. Substrate and enzyme can be easily replaced. Rotary drum bioreactor. In this, the drum is filled with 40% of its volume and rotated by means of rollers. It is particularly suitable for the cultivation of the plant cell cultures. Advantages of rotary drum bioreactor. High oxygen transfer. Good mixing facilitated by better growth and impart less hydrodynamic stress. Disadvantages of rotary drum bioreactor. Difficult to scale up. Mist bioreactor. This is suitable for hairy root cultivation of plant cells. Static root mass is contained in a chamber that is mostly empty. Nutrients are supplied as mist of fine droplets suspended in circulating air currents that penetrates the spaces between the roots. Advantages of mist bioreactor. High oxygen transfer. Hydrodynamic stress elimination. Low production cost. Disadvantages of mist bioreactor. Mesh trays and cylindrical stainless steel meshes are required. These are the different types of bioreactors for providing optimal growth conditions for the microorganisms. Operating modes of these bioreactors will be discussed in the next presentation.